Okay, let's start. So, last time we were talking about kinematics, we were talking about anti-differentiation. So remember that if you have a function and you differentiate, what you're going to do is multiply by the exponent, right, times the coefficient, and then subtract 1. So to anti-differentiate, we're going to do just the opposite. We'll add 1 to the exponent, and then not multiply, but divide by that number. Keep in mind, you're just doing exactly the opposite thing to return it to its original function. Now, we're still going to be working with the same types of functions where we have distance, time, velocity, and acceleration, but we're going to be going backwards. Say we'll start with the velocity, and what would I do if I started with velocity to get to s? I'm just going to have to anti-differentiate what? One time, right? But if I start with acceleration and I want to get to distance, I'm going to have to do it, what? Twice, okay? Now also remember that when we do the anti-differentiation, we get some terms, but then we get that constant term, that c. There's always a number at the end. And because remember that if you do the differential, then the differential for any number, if you take the derivative of it, you're going to always get a 0. So the number part of every function has gone away. When we're coming back to it, we need to find a way to put it back in, right? So so the first ones we're going to look at, we're going to concentrate on how to find that c, that number part. Okay? So let's go to the exercises. So that's on page 73. That's where those start. And let's look at the example that they give us so that we can understand what's happening. So remember that we depended a lot on the fact that t is equal to 0, s is equal to 0, and velocity equals 0, etc. And we talked about the times those happen. T is equal to 0 when you first start, right? S is equal to 0 when you first begin, or when you get back, if you're making a circle, right? If you're coming back to the same thing. And velocity is equal to 0 when you begin, and when you end, and also in the middle, right, at the very maximum part. Well, it may not be in the middle, but at the maximum velocity too. So that one's a little odd. We also get a 0 at the maximum velocity for that one. Okay? All right, so we're going to use those ideas to be able to get our c back when we do the anti-differentiation. Okay, so we're going to work backwards. Sometimes the context will be what tells you, right? So say if I'm going to throw a ball, before I've thrown it, then both time and distance and velocity, all of that are equal to what? 0. Okay, so they may not say that it was 0, but they may say that before you throw it or at the time you're going to throw the ball. So watch the context for that to be able to get some of these clues. Okay, so let's look at an example that they give us. It says a skyrocket is fired vertically into the air from the roof of a 60-meter building. Okay, the velocity is given by 50 minus 10t, okay, where velocity, of course, is measured in a certain kind of units. Velocity is measured in what units? Meters per second, right? How about acceleration? Meters per second squared. Distance? Meters. And time? Seconds. Right? And you'll stay with those measurements. So if we're going to calculate its vertical height, I need the formula for height, right? Not the formula for velocity. So to get to height, what we'll do is first simply take the antiderivative. So that means we're changing the function to an s function. And instead of subtract 1 and multiply, we're going to add 1 and then what? Divide. So this one, the 50 doesn't even have a t in it. So what's going to happen is it's going to end up with a t to the first, right? And 1 times 50 gives us 50. That one's pretty easy. This one, the t to the first is going to become t to the second. And then we'll take this negative 10 and divide it by 2 gives us negative 5, right? Okay, watching your signs. And then, but we always, at the end of each one of these, have some constant, so a plus c. Okay? Now, we know that when we start this thing, we know that time is equal to what? 0. Okay? And in this particular case, we're going to fire it off the roof of a building, right? And what did it say about the height of that building? So at the beginning, this thing is already 60 meters high. Now, many times that's not going to be the case, but this time we're starting from the roof of the building, so it's already 60 meters high, even at the very beginning. Well, if I know these two values, t and s, I can simply substitute them in and solve for c. Right? What if it said it was firing from the ground? What would s be then? 0. Right? So you'll just gain the context from the question that they give you, and they'll bounce that around quite a lot. Usually they fire it from the ground. It's unusual to have the 60 meters. All right? So in place of s, I'm going to put what value? 60. In place of t, I'm going to put what value? 0, which is really nice because multiplication by 0 just makes zeros, right? So it just eliminates those terms. So it ends up giving you 60 equals c, and don't have to solve anything, right? Because the c is already completely by itself, so I know that c is 60. So I can now complete my function. My s function is now 50t minus 5t squared plus what number? Plus 60. All right? And most of the time, because you're talking about when it starts, t will be 0, s will be 0, so that means c will also be what? 0. Excellent. Good logic. Okay? So most of the time, if it's not fired from a building or you're holding it in the air or doing something else, then it's going to be 0. But you can't just assume that, right? Now that I have my function, I can answer questions about it. We want to calculate its vertical height after 2 seconds. So I simply want to evaluate this when t is 2 seconds. So all I need to do is plug that in. So let's do that. So s is equal to 50 times 2 minus 5 times 2 squared plus the 60 that I found, which gives me 100. 2 squared is 4 times negative 5 is negative 20 plus 60, which gives me 160 minus 20, which is 140. So, and that's an S, so I need a unit. What kind of units? Meters.
Wait, sorry, where did the 2 come from?
I'm sorry? Because the question, it says calculate its height, its vertical height after 2 seconds. So that was a second part of the question. Good question, though. Okay? All right. Never hesitate to ask. I always hated it. I sat through my math classes going, okay, I don't know where she got that 5, and I'm not going to ask a question, right? But it's important we know. Do not hesitate to ask. So how does that look? Pretty clear? Now, of course, because the mathematics is easy, what are they going to do to you for the questions? They're going to give you lots of little twists and turns, right? Okay? So what we'll do is we're going to go through a few examples from your homework. Okay? We're not going to do them all because you need to do them all. But we're going to go through a few examples just so you can see. And I'm going to pick some that are very straightforward, and then I'm going to pick some that have a little bit of a twist, just so that you've seen some of all of it, right? Okay? And then I'm going to set you loose and let you work a problem. And then next time, it's going to be mostly you. Okay? Because we're going to end to differentiate twice. So that'll be your second homework, but we'll look at an example of that as well. So let's just look at, let's just do question 1. It says, okay, so we have our process. Let's write down our process first, I'm sorry. So first, we need to take the anti-differentiation. Can I say that word? Nope. Can't spell it either, I noticed earlier today. Okay? Then we're going to substitute for t and for s. Not just one of them this time, but for both of them. Okay? Then we'll solve to find c. Because we don't have a full picture of what's happening if we don't have our c, right? And then finally, substitute the given value, right? Like they gave us the 2 in that last one, with a given value to answer the question. And you could be looking for, because we're using that distance formula, you could be looking for the distance or you could be looking for the time. They could bounce around, right? So make sure you're substituting into the correct variable. Everybody okay with that?
Yeah.
Couldn't be much easier than that, could it? All right, good job. So let's look at it. So look at number 1 on page 74. It says a rocket is fired vertically from the ground. That's good. That's good news. The relationship between its velocity in meters per second and the time since it was fired is given by v equals 100 minus 10t. Calculate the height of the rocket after 2 seconds. So we're looking for a height. So can I use this velocity formula if it's for height? No. I need to get that into a height formula, so an s. Well, I know that you get from s to v by taking the differential, right? So that means to get to the other way around, I just need to reverse it. So here, the 100 doesn't have a t, right? So it's going to get a t in it, and it's t to the first, so 100 divided by 1 is still 100. Here it's t to the first, so that's going to come down as t to the second when we add 1 to the exponent. And what do I do to the negative 10? We're going to divide it, right? It gives us negative 5. But remember, we have that plus c business. We don't know. And we don't know what c is. But we do know some things. If you're going to fire a rocket, before you fire it, what is the time? And this time it says that we're firing it from the ground. If you're firing it from the ground, what is s? 0, right? So we're not on top of a building. It's not on a platform like it was last time. So that means everywhere there's an s, I'm going to put 0, and everywhere there's a t, I'm going to put 0, which we're going to love because if you replace those variables with zeros, everything that has a variable that has a 0 in it is simply going to be 0. Now, be careful. You know that to get excellence, which you're all going to get excellence, you need to show every step. So, even though you might be able to do that in your head, right? You know what the answer is. Have the confidence, that's fine, but show your work, please. Okay? So now that I know what C is, I can finalize my formula, or my function, I'm sorry. So do I even need the plus 0 at the end?
No.
No. So I can just get rid of it. So there's my function. And they want to know how high the rocket is after 2 seconds. So that simply means everywhere I find a t, I'm going to replace it with what? 2. So 100 times 2 minus 5 times 2 squared gives me 200 minus 20, which is 180 meters. Don't ever forget your units, right? How happy are you right now? Sad that you have to do it, but happy that it's easy. I hope. Okay? Any questions about that? Let's see. Okay.
Yeah, that's fine.
Pardon? Number 2 is what you want? Okay, I can do number 2. All right, we're only going to do 2 of them, so number 2 is the one you want. That's what we'll do. Okay. So a weather balloon is released from ground level. It rises at a velocity of 3 minus 0.2 t kilometers per hour. How high will it be after 2 hours? What's different here? They gave us, instead of seconds, they gave us, but is it in hours all the way through? So who cares? It just means our answer is going to be, we're going to use hours instead of seconds. We don't need to convert it. Now, what if it gave us meters per second, or kilometers per second and kilometers per hour? Yeah, we'd have to fix one of them. We could either change the seconds to hours or the hours to seconds. So make sure the units match. But since they do here, we're in good shape. So, okay? All right. So our velocity formula is 3 minus 0.2 t. And so we need the height. So we're doing an S formula, or you could also call S what for height? You could use H, either one, right? It says it's released from the ground, which tells us that the height originally is 0. And when you first release it, that means also t is also what? 0. Doing the anti-differential, that's going to give us 3t. That's going to become a t squared. So I take negative 0.2 divided by 2. Anybody want to give me that answer? 0.4 when you divide them? Be careful. What are we doing? 0. What?
1.
There we go. So remember, when you're going backwards, you're dividing here. Plus our c. Now, can anybody tell me what c is going to be?
0.
Yeah, because everything else is 0. So it's 0 equals 3 times 0 minus 0.1 times 0 plus c. So all that's going to go away, gives me 0 equals c. So now I have my height function or distance function. I don't care which one you call it. 3t minus 0.1 t to the second plus 0. And, of course, I don't need plus 0, so we'll just leave it off. We know it's a 0, though, right? So we don't need it. Now all I need to do is answer the question, how high will it be after 2 hours? Now our formula is in hours, so we don't need to change it to seconds. So we're just going to use t equals 2 hours. So S equals 3 times 2 minus 0.1 times 2 squared, which is 6. 2 times 2, 2 squared is 4, times negative 0.1 is negative 0.4? Okay, everybody's happy with that? And what's 6 minus 0.4? 5.6. What? They changed our units on it this time. They used kilometers instead of meters. But since it was consistent, we don't have to worry about those units. We just have to worry about writing down the right units at the end. Look at number 3. I'm not going to do it, but I just want to walk you through it because it has many stages. So if they give you velocity, we can't use velocity. We have to change that to height, which means we have to find our c. But that's easy because we're always going to do that at the beginning. So time is what? 0. Distance is what? 0. Okay. Now, how far will it travel during the first 10 seconds after the brakes are applied? So when the brakes are applied, it changes the velocity. Yeah? Okay, so when we're working on that, so let's go ahead and just look at this one, because it's got a lot of parts on it. So we started off with velocity equals 28 minus 2t meters per second. So we differentiate, which is going to give us 28t minus 1t squared plus our c. And again, we know that when we're working with this, we usually have to have a t and an s to be able to do these, right? But it says a car is already traveling a constant velocity of 28 meters per second, right? So it's traveling at that speed already. So if it's traveling at that speed already, then we have a distance that's slightly different this time. Is our distance 0? No, it's going to be, our time is going to be 28 meters per second. Okay? And at maximum velocity, just go ahead and assume that's a 0, right? So we have a time. Our time is going to be very different here because we're already moving. Now watch how all we're going to do though is simply plug that weird number in there, and it's all fine. So s is going to be 0 at our maximum velocity because our maximum velocity before we brake, right? Okay. So we're going to get 28 times 28 meters per second, and all those meters per seconds and everything are going to go away in a minute. Minus 1 times 28 meters per second squared plus our c. So the time that we're traveling is given by that function. And then so we get 0 equals, here, it's just 28 times 28, which is 784 meters. And so, let's see, per second, over second, minus, here 28 squared, which will give us the same exact number, right? Okay. Oops, meters. So what's going to happen is, those numbers are the same, aren't they? So they're simply going to subtract away. So it doesn't matter that we got weird numbers to begin with. They're simply going to subtract away, and it still gives us what?
There.
Yeah.
So the only time c will ever equal something is if distance is given.
If the distance is given, right. This is never going to really affect your c. That might. Okay? So if you get two things over here that are not opposites, that don't subtract away, probably, or make 0 somewhere, then yeah, you probably got an issue. Now, so that gives us a c of 0, so that means that our distance formula is simply the anti-differential without the, right? So and we obviously don't need the plus 0 at the end, right? So there we go. So let's see. It says how long after 10 seconds after the brakes are applied. So that means we know we're using our new formula after the brake, because that's what happens after the brakes are applied. So just use t equals 10. And you don't have to put the 1 there, right? I'm just doing it for effect. Remember, I'm always going to write more than y'all probably will. But I want you to make sure that you understand where every number is coming from. 10 squared is 100, times negative 1 gives you negative 100, which gives you 100, and this is measured in meters. Okay, so 180 meters. When will the car stop? Sorry?
When will the car stop?
Okay, if it's stopped, what thing is 0? Yeah, it says when, so that means we're looking for a time, right? Remember those two clues. We can look for when, where, and how fast, right? When is time? Where is s? How fast is velocity? So don't forget what we've already learned. So we're looking for when. That means they're going to have to give us some number to put in for distance. And if it's stopped, distance is going to be what? Is it going anywhere? No. So 0. Okay. Let's see. Where are we now? So just said that wrong. It's not distance equals 0. You still went somewhere. What are you not doing? So what's 0? There you go. So you go back to velocity formula. Because you still moved, right? So it can't be the S formula. You're looking for time, so it's got to have time in it, but don't they both have time in them? So you're just asking when it stopped. So that's velocity. So 0 equals 28 minus 2t. Going back to the velocity. Sorry about that. I misspoke. Okay? Look at the next one. After what distance does it stop? There's where you need the what? That's an S. You're looking at the distance. Okay? After what distance does it stop? Well, I know from working this one out, so let's go ahead and work that one out by adding 2t. Many of these are going to be two-part questions where you can't answer the next part until you've done the second part. Divide both sides by 2 gives me a time of what? 14 seconds. Now, and we said that's when the velocity ends, right? Velocity is 0 at that time, which also means that is the time when the car stops moving, right? Doesn't go any further. So at what distance does it stop? That's when the time equals 14 seconds. So plugging 14 into your distance formula and then working that out, and you should get 196 meters when you work that out. Okay. Let's see. Calculating the distance, if you drop a rock, you're looking for distance or depth. That means you have to change V to what? S or H. Either one, okay? Then it says a Martian on Mars drops a rock into a cave. Does that have anything to do with anything? No. Do not get confused and start thinking, oh my gosh, there's no gravity or whatever. The gravity is different. Don't worry. But there is something different there. Okay, hold on, guys. Look up here. He's holding the rock 2 meters in the air before he drops it. It's a very tall Martian. So what is that? So is that 2 meters part of the depth of the cave?
No.
So once I get my number, what am I going to have to do about that 2 meters? I've got to subtract them out, just like we did last time when we had one similar to that, right? Excellent job. Okay, now I think that we can go on and do acceleration because it's the same thing. You're just going to have to do the anti-differentiation, what? Twice, okay? So let's look at the example, and if you have a lot of trouble with it, remember we'll talk about the questions when we're in class. But just remember that if it's asking for maximums, right? That's 0, and you may have to calculate velocity after a certain period. So this is on page 76. So we're talking about given acceleration, calculate velocity. Oh, they're even being nicer to you. You're only going to have to do it once, right? So these are just like the others. So for example, a snowboarder begins to move down a slope with an acceleration given by A equals 0.36 t squared plus 2. Calculate the velocity of the snowboarder after 5 seconds. Okay? Well, I can't use the A formula to do that. I have to change that to V, which simply means I have to anti-differentiate. So that's a square, so it's going to become t to the third. And I have to divide the 0.36 by 3, which is going to be a what, guys? 0.02. Good job. That 2 doesn't have a t in it, so that's just going to become t to the 1. And positive 2 divided by 1 is positive 2. And then plus what? C. Okay? Well, if you're just beginning, so he says he begins to move down the slope. That means our time is what?
0.
And he begins to move down the slope, which means our velocity is what?
0.
Okay? Which means when I put the zeros in place of each one of these, and in place of that one, it's going to give me c equals 0. Right? So now I have my velocity formula. plus 0, so I don't need it. Who cares, right? Okay. And so after 5 seconds, that simply means to replace the t with 5 and work it out. Hopefully you have your calculators handy, because I don't, and I cannot do all of that too. So 5 to the third power is going to give you what? 5 to the third means 5 times 5 times 5, so 125. And 125 times 0.10 is, I'm sorry, 0.12, I'm sorry. Anybody? 15? Thank you. Sorry, he was saying that, somebody over there. Plus 2 times 5 gives you plus 10, which gives us 25, and it's velocity, so what? Meters per second, exactly. Okay? And it looks like they're only taking you from acceleration to velocity. Ah, there we go. And then the next one on page 78 is when they start doing both of them. So we'll save that for last, and we'll also, though, go over a review of all the things that you're going to need, because there's still one internal assessment you have to make on this, right? Okay? All right, so let me stop the recording there. Homework. So what I want you to do, we've done some of them, so you can just write them down, but I'm still going to put it in there. So in page 74 and page 76 is where they began. And I want you to be able to do them all, okay? At this stage of your life, you should be able to do all of those. And the next time, we'll come in and we'll talk about when you have to anti-differentiate twice, and then we'll review and get you ready for your next assessment, which I'll have to figure out when that happens, because I don't know.